No, stop it. Stop it. Taga, stop it. Don't touch my head. Don't touch my head. Taga, don't touch my head. Oh, he's gone. That was Taga the alien. He was trying to hack my brain. Thank you for being with me. Now I can continue with what I was doing. I failed quadratic, I failed parabolic. So, thank you. Welcome to Uncle Ken channel. If you're new here, please subscribe. If you're a subscriber, thank you very much, and share the video. Welcome to part 2 of solving quadratic equations using Po-Shen Loh method. We're going to start with this equation here, which is straightforward, which is x squared plus 5x plus 6 equals 0. But the way we solve it normally, we start by looking at the constant and looking at the factors which we multiply. When we multiply those factors, we get 6, and when we add those factors, we get a coefficient of 5. So in this case, we put in x there and x there, and we know two factors that multiply into 6 and add up to 5 is 2 and 3. So plus 2 plus 3. And then we solve each one of these equations separately. So we got x plus 2 equals 0, and therefore x equals minus 2. X plus 2 equals 0, x equals minus 2. That's one solution. The other solution, x plus 3 equals 0, therefore x equals minus 3. That's the second solution. Now, but this is straightforward, and it's quite nice if you're dealing with simple equations like this. So we're going to try to demonstrate using Po-Shen Loh method. And the first place to start is to use the power of symmetry. So that's a quadratic, these are quadratic curves, for example. And I'm going to start by reminding you the quadratic formula, which is going to solve for x equals minus b plus minus square root of b squared minus 4ac over 2a. Now, I want you to focus on this bit here. That part of the formula, b squared minus 4ac, is called the discriminant. It discriminates what type of equation. For example, if the discriminant is less than 0, then you have no solutions, because as you can see from the curves, they do not intersect the x-axis. If x equals 0, then the quadratic curves touch exactly the x-axis. For example, that and that one. If that discriminant is greater than 0, then you have two solutions. One solution is here and there. The other solution is there and there. So these curves have got two solutions. These have got one solution. These have no solution technically, but we use complex numbers, then we can solve those equations. Now, so this is the place to start. If I have the line of symmetry, and I can find say for example, I'm just using this equation to demonstrate. I know this is negative 2. That's negative 2. And that's negative 3 for this solution. And the line of symmetry, because it's between the two, it must be negative 2.5. Oh, I could say it's actually negative 5 over 2. That is the line of symmetry, which is equidistant between the two solutions. Now, as you can see, this 5 over 2 is the same as that coefficient of x divided by 2 and then multiplied by negative. So it's negative 5 divided by 2. We're going to use that method for that sake. Now, what we're going to do is we're going to say this bit here is u, and this bit is also u, because they are equidistant. So I can say, therefore, this here is negative 5 over 2 minus u. That will give me that value there. If I multiply that by negative 5 over 2 plus u, which is that there, will give me 6. Because that's with following the same rules. So now, at this point, we have a very beautiful thing we can do with this sort of equation. Because we know that when you got a minus b multiplied by a plus b, this is the difference of squares, which is a squared minus b squared. So we can use the same and multiply out that. So negative 5 over 2 squared, this will be 25 over 4 minus u squared equals 6. We take this 6 as it is, but we only put negative on the half of that coefficient of x. So now we can just make u the subject. We can just swap these numbers and we'll have 25 over 4 minus 6 equals u squared. Now, 6 is the same as 6 over 1. And I can just multiply that by 4 and that by 4. Therefore, I'll get 25 over 4 minus 24 over 4 equals u squared. And this 25 minus 24, that will give me, I'm just going to use this same bit of paper here. That will give me 1 over 4 equals u squared. And if I want u, I can just square root both, and therefore u equals a half. That means that little bit there is a half, and if I substitute that negative 5 over 2 minus a half, what is that? Minus a half will give me 3, because I'm going that way. That one, if I substitute this u there, that will give me negative 3. And that one will give me negative 2. And I have the same solutions as I got when I did this. The question is, why use such a long method when we could just actually, factorize? There are two reasons. This is the beauty of symmetry we've used here. We are not guessing at all, and we're working logically from the end, and the thing is, this is a very simple quadratic equation. We can use this method to solve difficult problems without having to use the quadratic formula, without using a calculator. Actually, you can just do it that way. So that's how it's used. It's done. So we got the next question here, which is x squared plus 6x plus 9 equals 0. This one we don't have to work through all this. We can jump a few steps. So take this 6, put negative and divide by 2. So we got negative 3 minus u. So we got negative 3 minus u multiplied by negative 3 plus u equals 9. And we know this one is the difference of squares. Therefore, it's 9 minus u squared equals 9. And we can swap this. So we have 9 minus 9 equals u squared. And 0 equals u squared. Therefore, u equals 0. If u equals 0, then I need to substitute here. So therefore, negative 3 minus 0 is negative 3. And we got negative 3 plus 0 equals negative 3. So this the solution to this is just negative 3. And it's one of those equations here. That means the discriminant of this equation is actually equals to 0, and you can see from the demonstration here. So b squared minus 4ac, this is b squared is 6, so is that is 6 minus 4 times 9 times 1, which is 36 minus 36, equals 0. And we have solved it quite quickly. And that is the end of this part of the video. We're going to work now on slightly more difficult equations with a coefficient of more than 1, coefficient of x squared more than 1, and also one equation where we have a complex number. That's the part 3 of the video. Thank you very much. See you in part 3.